All right, guys. So this is where we're starting today. We're finishing up section 1.1. So the first thing we're going to look at is interval notation. And we will graph some of these if they aren't already graphed. But this is what we're looking at, interval notation. So interval notation is using our parentheses and brackets. So parentheses, if we use parentheses, it means that that number is not included. It goes to that number but does not include that number. If the number is included, it is equal to it, we use brackets. So if we look at the first one, A, -2 is less than or equal to x is less than or equal to 3. Well, we would have -2 and 3 as our endpoints because this is a bounded interval. And we would use what? Brackets. It's the new note sheet A. There's this. Yeah. That looks. I really need to fix these note sheets. Yeah. Okay. I have a feeling. All right. Yep. I somehow lost these slides in the mix.
They don't match.
Yeah. So let's follow along with this here, and then I believe probably on the next page. Yep. Then we'll pick those up there. So I'm. Yep. You can follow along with this here because this is, I think, more of a refresher than anything else. Is going over doing interval and interval notation is something you've done in Algebra 1. Y'all did this with Miss Kendall. But that has been a little bit. For this one here, this next one is an unbounded interval. It's got one endpoint and is going to continue on in one direction or the other. So x is greater than -1. So one of our endpoints is -1. Now, since it's getting bigger than it, it's going to go from -1 to infinity. Now, infinity, positive or negative, will always have a parentheses. And because it's not equal to it, -1 will also have a parenthesis. If we wanted to graph this on a number line, -1 would be one of our points, and it would have a circle, and we would shade to the right. -1 would stay open because it's not equal to it, but we would have this here. Any questions on this so far? Let's look at the next one.
So how it's
Closed.
like the box there.
Because it less or is greater than or equal to, then we would use a bracket. If it's not equal to it, then we do not use a bracket. Now the next two we have as graphs on a number line. Now when I look at C, we do have two definite endpoints. We have one at -3 and we have one at 4. So if I'm going to write this as an interval, we'd have 3, 4. 3 is included because it's shaded in, so it's going to have a bracket. 4 is going to have a parenthesis. And that's it. If we wanted to write this in as an inequality, we would say -3 is less than or equal to x is less than 4.
Good morning, Concord High School. Please stand for the Pledge of Allegiance.
Questions on this so far? Questions on inequalities or intervals? Yes.
How do you know if it's a parentheses or blue box?
If it is equal to. So if we're, yes, thank you. Because the main way that we know if it's parentheses or equal, or kind of understanding which one it is determining if that number is included or not. So included means equal to, that the value is true. So if we're saying here, so the first one, -2 is less than or equal to x. So is -2 included? Can x be -2?
Yes.
Well, yes. So we would use these here, these brackets, these box, because it is included. Well, included is equal to it. It is contained within it. If it's not equal to, x is greater than -1. X cannot be -1 and this be true. So it stays open. We have a parenthesis. Does that make sense? Awesome. And with inequalities, especially for C, going from the number line or these to our equation, because if we have that kind of box, that bracket, then it's going to be equal to. If it's a parentheses, it's not. So if we look at letter D here, we only have one endpoint, and it continues indefinitely to the left. So we know one of the numbers that's going to be included in interval notation is going to be 3. And the other number, because again we're going to the left, is going to be smaller than it, yes? So what number would that be? Negative infinity. Now negative infinity or positive infinity, if we have either one of those, it's going to have a parenthesis. It's just guaranteed. Because we can never reach infinity, we cannot get there, so it's always going to have a parenthesis. Now will the 3 have a parenthesis or a bracket? Bracket, because it is filled in, it is included. Questions on interval notation before we look at the inequality of this? Now, whenever we have an inequality that is unbounded, going in one direction, we're going to have x in one number. So we will have x, and we will have 3. Now, since it's going less than it, we're going to say x is less than or equal to 3. So whenever infinity is included, we're only going to have one number in x. We're not going to have 2. Questions on any of this here? Okay. I also realize that this is not listed on there also. Set builder notation, I would take at least some notes with this here, because I think the very back page is completely blank. Set builder notations uses symbols to define a set in terms of the properties of the members of the set. So I'm going to specifically tell you kind of what to write. I wouldn't write all of that. What I would write, clear all this, is this part here. So here is the atypical version of set builder notation. So what we'll have is a brace followed by this here. So it's, in this case, if there's nothing with it, it's the set of all real numbers x. This first part is describing what type of numbers are the variable going to be using. So here, when we just have x, we're talking about all real numbers. X is an element of all real numbers. Or we could say x is a whole number if we wanted to. This first part is describing what kind of numbers are we talking about. Are we talking about whole numbers, natural numbers, integers, rational numbers, irrational numbers, real numbers? The next part, this bar, means such that. That's going to be there every time. And this last part describes it. Describing what kind of numbers are we talking about? Are we talking about the numbers that are greater than 2? Are we talking about the numbers that are between 0 and 2? Are we talking about the prime numbers? Or all of the odd numbers greater than 4? It describes what kind of numbers we're talking about. And this here looks harder than it is. Because once we start looking at some of these, they're going to make a little more sense. Especially the more when we actually start doing these. Because we're going to start off brace, we're going to describe the numbers. What kind of numbers are we talking about? Whole, natural, integers. Such that, describe what type we have. So the first one here is for all real numbers x. Because if it's all real numbers, we just have to put brace x bar. Such that x is less than or equal to a, or x is greater than b. And they will give us most of all this information. We just have to write it in this form. Or the second one, for all real numbers x such that x is not equal to a. X is every number except whatever the value of a is. Okay, so we're going to jump around a little bit here. Any questions on this so far? So we've got this down, yes? No one's still copying? So we're going to skip this part here for now, and that one. I want to go to this, because I want to actually have us write in set builder notation first before we start digging into anything else. Write the set of numbers in set builder notation. Okay. A, the set of integers greater than 5. What kind of numbers are we talking about? The set of all what? Set of all integers. So what type of numbers are we talking about? Integers. Because it told us that we're talking about integers. We're not talking about just the real numbers. We're specifically talking about integers. So this tells us what kind of numbers we're using. We are using the integers, which means we're not talking about fractions. We're not talking about irrational numbers. We're specifically talking about integers. And what do they tell us about these numbers? What are they going to be? Greater than 5. So greater than 5, if I wrote this as an inequality, because with any of these here, these statements, if we're talking about greater than less than, it's got to be an inequality. It can't be an interval. So we can't use parentheses and brackets. So as an interval, x is greater than 5, x is greater than 5. That would be it as a inequality, yes? Yep. Questions on this so far? So we did have a symbol for integers yesterday. What was that symbol? Z with an extra line, yes? Yes. Because I'm going to show you two ways. One of them is going to be the pure mathematical way to do this, and the other is going to be a little bit easier. Or not so much easier, but another way we can write it. So we start off with brace, because as we wrote on the back of the paper, because it was brace, describes our number type such that our description. So x, we can leave x by itself if we're talking about all real numbers. But here we're not talking about all real numbers. We're talking about integers. This is going to be a new symbol. Well, new in the sense that in the context we're using it. You've seen it before. It looks like an E. In mathematics, this symbol means element. X is an element, or X is a part of the what? What are we talking about? Integers. So here, instead of saying for all real numbers, we are saying for all x, all values of x in the integers, such that, what did it tell us our x was? That's set builder notation. textbook is going to do this a little different, so if you're checking, make sure you got it right. What they're going to do, and this is not wrong, is going to start out with this. They're all real numbers x such that x is what? X is an integer and x is greater than 5. Says the exact same thing, but just a little more writing. Interested to hear if you all have any questions. What do we think of this so far? It can be a little bit confusing because, again, this isn't something you're used to. This is new. Which way do y'all like better, the one on the left or the one on the right? One on the left. It's a little more simpler than the one on the right. Because here, we're describing the type of numbers. Intervals, like this here, is going to be all real numbers. If we are not told specifically it's something other than the real numbers, or not specifically told what it is, default to all real numbers. Default to all real numbers, because that's going to describe anything and everything. All of our numbers. The only ones it won't is imaginary, and we're not going to talk about those yet. So here, we're talking about all real numbers, which is going to be nice. We're not going to have to do anything for the first part, excuse me, of this statement. But unfortunately, we can't leave it in interval notation. We've got to write it as an inequality. So we have an OR statement, yes? So this has two parts. Let's look at the first part. Negative infinity, comma, -1. That means what? We have one endpoint, yes? We have -1. And we'll have x. What will be the symbol that goes between them? So greater than, less than? So let's look at a number line. So if we had a number line, -1, we'll put a circle here. Would the circle be open or closed? Open, because we have a parenthesis, yes? Which means this will not be equal to. Because if it's closed, we have a bracket, that square-shaped one, it would include it, so it would have an equals. But here, parentheses means it's open. Which direction is it going? To the left or to the right? Which? Left, because that's the direction negative infinity is, yes? So what's going to be bigger? -1? X is -1. So if drawing the graph out helps, draw the graph out, graph it. Because we could do the same thing over here. Because we also have -1. We'll have a circle here. Will this circle be open or closed? Open. Which side are we shading? Are we shading to the right of it, to the left? Okay. So we'd have -1 and x again. Any questions on how we wrote this as an inequality? So we good with writing this as an inequality? Unless it says otherwise, this is where we're starting. And what I mean by otherwise, like the last one, x is an integer. X is a rational number. If we have any of those kind of statements, we're not starting with this here. But if we have x is a real number, or x is a part of the real numbers, or just interval notation, it's going to be all real numbers. So that means for our set builder notation, we're starting out with brace X bar every single time. Now we need the description of the numbers, yes? Oh, wait a minute. In this right here, describing what kind of numbers we have. Copy paste. That's it. Questions on B? Any questions on either one of these here so far? Are you ready for the next one? Negative infinity, comma, -1 bracket, or 1 comma infinity. So again, the first thing we need to do with this here is rewrite these as an inequality. So we can start off with negative infinity, comma, -1. It has exactly one endpoint. One of the main reasons we know it's just going to have one endpoint, one number is because infinity is included. If infinity is included, that means we don't ever, well, let me rephrase that. We don't ever list infinity or negative infinity in an inequality. We just don't list those. They're not specific numbers. They're more of a conceptual idea or an understanding of what is happening. So here we'll just have x and -1. Is -1 included? So we will have part of our inequality symbol, the equal sign. Now we need to figure out which direction the arrow is going. Yes. Because if we graph this part, we would fill in the point at -1. And since it's going to negative infinity, it's going to the left. We'd have this as the graph for the statement x is less than or equal to -1. Or 1 comma infinity. So we will have our 1 and we will have our x. X is greater than 1. Because here, if we graphed it, we would have 1. We wouldn't fill it in because the parentheses next to 1 tells us it's not included. And we're going to positive infinity, so we would shade to the right, which is our x is greater than 1. Now that we have this, we need our statement. Brace x bar. So again, if we start out in interval notation, or really they just give us straight inequalities to begin with nothing else, we're starting off with this, all real numbers. For all real numbers x, such that what? Our description. It's very nice, especially if they start out as an inequality, if they had just given us x is less than or equal to -1 or x is greater than 1. Brace x bar, fill it in, brace. That's it. The set of all integers except -4. This one should be y'all's favorite one out of every single one. Because -4 is the only one we can't have, yes? So x, so I'm going to do x and -4. Does anybody know the symbol for not equal to? So we're saying that x is not equal to -4, yes? So set of all integers except -4. Well, we're saying except -4, which means x cannot be -4, yes? Do we have the description? What kind of numbers are we talking about? Integers, okay. So I can't have our brace x bar because it's not real numbers. You have to say what? X is an element of the and that's actually it. If it had said the set of all real numbers except -4, it'd look like this here. Because if it's just saying the set of all real numbers, I don't need the z anymore. We can drop it and the element symbol and just have this. Questions on this here? So yes, I will tell you that this is new. This is something that y'all are not used to. For the most part, set builder notation is not something that you're going to do a whole lot of unless you specifically go into a pure math field of study, which is just pure mathematics. Going into proofs and higher level mathematics, then you'll use set builder notation and use these to kind of set proofs up, talk about the numbers that we're going to look at, especially in general equations. But other than that, we will see it for this here, this chapter. It will show up on the chapter test, and then we won't see it again. Okay? Questions on any of this here? Okay. I think of where we're at. All right. We'll look at these here, the set of all whole numbers, 50 through 54. So whole numbers. So this is subsets. Again, this section, I really need to fix these note sheets for this chapter, and I say that every year. Because our subsets are what we kind of talked about yesterday, where we're listing the numbers out. And realistically, looking at this here, so whole numbers, non-decimal, positive counting numbers greater than 0, yes? So can anybody list the whole numbers 50 through 54? So what's the first one? 50. Done. Because if we can list them, we're going to list them. Especially with whole numbers, it's easy to list them, yes? Okay. So that's all we have to do. Now, if it had said the whole numbers greater than or equal to 50, if it says greater than 50 and you give me 50, I'm not going to be a nitpick about that because it should start at 51. Or here, if it's specifically talking about through, then it, as y'all did, 51 would be the start. I'm not going to knock y'all off of that. But even if it said greater than 50, at this point here, we could have put dot, 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 and it continues on. Because whenever we have the dot, 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 it says whatever that pattern was that we have set up is going to continue on. Does that make sense? Now let's look at the next one. The real numbers, 0 through 4. So what's the first number between 0 and 4? Well, we could say 1, we could say 0, either one, I'll take either one. So if we say 1, what's the next real number after 1? 1.1. Because real numbers is any number. Well, 1.1 is not really the next number. It's 1 point, a whole bunch of zeros, and then 1, yes? And then that increases a little bit and a little bit. So is there any way I could really write the numbers from 0 to 4? So we can't just list them, right? So we need to define them.
Come to the office. David Shipley, come to the office.
So here we have to write it as an, we can say interval or inequality. Because an interval would be what? 0, comma 4.
It also brings schedule custody down, and it is also time for the softball girls to leave. It's also time for the softball girls to leave. Thank you.
Or as an interval, or as an inequality, we would say 0 is less than x is less than 4. Because with this being real numbers, there's no real way that we can list all the numbers between 0 and 4, actually write them all out. Because the distance between 0 and 4 is massive with the number of numbers that fit between 0 and 4. And not even that. The number of numbers we can fit between 0 and 1 is infinite. Because we can start out with just say 1 over. I'm going to write this down. So 1 over a number. So every positive number that exists, I can put it in the denominator of this. Well, we have an infinite number of positive numbers, yes? So even here, just doing that, I've got an infinite number of numbers. But we also have so technically, we have an infinite number of numbers between 0 and 1, let alone 0 and 4. Kind of make your head hurt a little bit. Taking the whole concept of just 0 to 1, which we thought was not a whole lot of space, and now it's, yeah. But we do have some set boundaries to it because we know 0 to 1, we can't just write it massively. We do have some constructs so that we don't just break our head thinking about that or trying to fit those numbers in. We just understand that there is a lot of space between there, but we have this here. The integers, negative 1,000 through 1,000. Yes. I don't know where I got 1,000 from. Negative 100 to 100. Well, the first integer is negative 100, yes? Yeah, pretty much. Because we gave enough to establish a pattern of what we're doing and gave it an endpoint. We're going to stop there for today, and we're going to finish this up tomorrow. I will also give you all some time to work on the assignment in class.